Hi everybody. So this is going to be a video on how to solve trig problems that identities may or may not solve. At the very least, problems where maybe you could solve it with an identity, but you don't necessarily need to. Maybe it might actually make things a little bit more complicated for you. So here's an example problem. We want to solve sine of 3x equals negative 1, and we want to find the solutions over the interval 0 to 2 pi. So the way that I think about this is, first, just pretend we're not even working with like multiples of angles or anything like that. Let's just answer the simpler question. Where does sine of theta equal negative 1? And obviously, if you're watching this, take half a second. If you don't know, pause the video if you need to, and answer that for yourself. Where does sine of theta equal negative 1? Well, it's at theta equals 3 pi over 2. That's the only place. All right, but we're not solving this for theta. We're solving it for 3x. So essentially, we're solving where does 3x equal 3 pi over 2? And if you divide through by 3, that's at x equals pi over 2. Great. And if you get right here and you just box this thing off and you submit it to your, maybe it's on an exam or your homework or whatever, you just box it off, you move on to the next problem, you're going to get it back and you're going to be marked down. And your instructor is going to say, yeah, there are more places. There are more solutions. And that's kind of the main thing to be careful of, because obviously we can do a quick mental check. If I plug x equals pi over 2 into here, sine of 3 pi over 2, yeah, that's negative 1. But because of this 3 in here, there are more solutions. So remember, if you think back to sort of like transformations of these graphs, how does this 3 affect the period of the function sine of 3x? What is the period of sine of 3x? The period of sine of 3x is equal to 2 pi over 3. Remember? 2 pi over b. That's the period. Which means that we can add onto this pi over 2. Every time that we add 2 pi over 3 onto this, we end up with the same solution. That x value, that new x value will be a solution to sine of 3x equals negative 1. So we're not asked for all of the possible solutions, but sometimes writing out all of the possible solutions might be helpful. What are all of the possible solutions? Well, it's x equals pi over 2 plus any integer multiple of 2 pi over 3. So plus 2 pi over 3 k, where k is an integer. So k is an integer. So the idea now is that what we want to do is we want to take pi over 2, which we already know to be a solution, and we're just going to continuously, repeatedly add 2 pi over 3 onto that until we push ourselves out of this interval. So pi over 2 plus 2 pi over 3, let's see, so this is 3 pi over 6 plus 4 pi over 6, which is 7 pi over 6. So here's another solution. If we plug 7 pi over 6 into here, then we end up, this will be a solution to sine of 3x equals negative 1. And 7 pi over 6 is still within our interval. So yeah, this counts as a solution. And then just keep adding 2 pi over 3. So 7 pi over 6 plus 2 pi over 3, which is the same as 4 pi over 6, so plus 4 pi over 6, 11 pi over 6. Another solution, which is in our interval. And if you were to add another period, 2 pi over 3 onto this, then you end up at 15 pi over 6, which is definitely greater than 2 pi. So this is the last solution in our interval. And those are all of the solutions. So we have the solution x equals pi over 2, 7 pi over 6, 11 pi over 6. Those are the 3 solutions. And I think that it's helpful to just do like a quick check. Think about it. So for sine of theta, if we're looking at the equation sine of theta equals -1, there was exactly one solution to that on the interval from 0 to 2 pi. Sine of 3x, this 3 in here, that kind of, you can think of it as speeding up the sine function. So in the time that it takes sine theta to complete one period, sine of 3x completes 3 periods. So if sine of theta had one solution over the interval from 0 to 2 pi, if sine of theta had one solution to this equation, sine of 3x should have 3 times as many solutions. So it makes sense that we have 1, 2, 3 solutions. How can you be sure that you grabbed all of the solutions and also be sure that you grabbed them correctly? Well, on the one hand, obviously, you can make sure that you grab them correctly just by plugging these back in and making sure that it does end up being the case that each of these x values leads to sine of 3x equals -1. That's how you can check that you've got that your solutions are correct. How can you make sure that you got all of the possible solutions? Graph it. So, and there are 2 ways of kind of graphing something like this and seeing all of the solutions. So the first one might be to graph 2 different equations. y1 is sine of 3x and y2 is -1. And then you see where does y1 intersect y2 over this period from 0 to 2 pi. So maybe if you're using Desmos, like restrict the period so that you can see exactly where it crosses the line. If you're using your calculator, restrict the x minimum and x maximum. So if you were to graph these, just kind of like a quick sketch of what it's going to look like, let's see, sine of 3x is going to do something like this. 1, 2, 3. There, from 0 to 2 pi. Just imagine that it's a perfect graph. You have to really use your imagination. And so that's y1. y2 is the line y equals -1, which should go through the troughs. Just a terrible picture. Imagine these things are all coming down and actually touching that line, because they would be. So where does sine of 3x equal -1 on this interval? It's all of the places that the 2 graphs intersect, which you'll find will be these three x values. So that's one way. The other way, which I think maybe is the better way of doing it, is solve the original equation, set it equal to 0. So in other words, add 1 to both sides. Sine of 3x plus 1 equals 0. So that's what we'll graph, is sine of 3x plus 1, and then we just want to see where that equals 0. In other words, where does it cross the x-axis? So it'll literally be this exact same graph, just shifted up 1 unit. So something like this. 1, 2, 3. And then these 3 spots, the so-called zeros of the graph, are going to be the solutions. So that's one way that you can make sure that you've captured all of the solutions, because that's the real danger with this. It's not terribly difficult to capture one solution. Capturing all of the solutions over the interval, whatever interval, that's kind of what causes most people problems. So let's try another one, maybe one that is not an integer multiple of an angle, but a half angle. So we want to solve, where does 2 root 3 times sine of x over 2 equal 3? Well, similar first step. Let's first just rewrite this, solve it for sine. So this is sine of x over 2 equals, I'll let you convince yourself of this. When we divide 2 root 3 over 3 divided by 2 root 3, and then kind of rationalize and simplify, it becomes root 3 over 2. So now we're solving, where does sine of x over 2 equal root 3 over 2? All right. Well, same idea. First, solve the simpler question, where does sine of theta equal root 3 over 2? Well, of course, that's at theta equals pi over 3 and 2 pi over 3. We don't want solutions in terms of theta, we want them in terms of x. So we instead solve, where does x over 2 equal pi over 3 or 2 pi over 3? and that's at x is multiplying through by 2, x equals 2 pi over 3 and 4 pi over 3. Okay, so we found two solutions. We need to convince ourselves, though, that these are all of the solutions over 0 to 2 pi. So what is the period of sine of x over 2? The period is 2 pi over 1/2, which is 4 pi. So we can add 4 pi to either of these angles to get another solution, but obviously 4 pi, adding 4 pi to honor either of these will push us well outside of the required interval. So these are the only solutions, x equals 2 pi over 3 and x equals 4 pi over 3. All right, let's try another example that relates to different trig expressions. So where does cosecant squared of x over 2 equal 2 times the secant of x? That's what we want to solve. Where does that happen? Let's see, there it goes. Right, so me, personally, I hate working with the reciprocal functions. I just do not like it. So I'm going to change this, rearrange it so that I can work with the more familiar functions to me. Well, how do I do that? Cosecant is 1 over sine. So cosecant squared of x over 2 is really 1 over sine squared of x over 2. And this is equal to 2 times the secant. What is secant? It's 1 over cosine. So if we multiply through by cosine, multiply through by sine squared of x over 2, we end up with cosine of x, the new equation, cosine of x equals 2 times sine squared of x over 2. And this is, by the way, a completely different equation than what we were first given. But the key point is that they'll have the same solutions. That's what we care about. It's kind of like when you're solving quadratics, if you remember back in college algebra. If you're solving a quadratic, you can multiply through by any number that you like, or divide through by any number that you like. And it will technically change the equation. Like if you were to graph the two equations before and after multiplying through by the number, it's a different curve. But what you'll see is that they both have the exact same solutions. They have the same zeros. So that's kind of why we're allowed to do this. Yes, we're solving a different equation, but it has the exact same solutions as the original equation. So now we kind of need to figure out how we want to deal with this. And yeah, this is a situation where you will need to use identities to rewrite this thing so that we can solve it like how we solved the last two. But which identity do we use? So I've got my sheet of identities here. So we're looking at cosine of x and sine squared of x over 2. So this is kind of what I'm looking at. On the one, there are two things going on here. One, there's the sine squared bit, and then two, there's also the x over 2 bit. The first time that I tried this, my initial thought was maybe I should write sine squared, rewrite it using the Pythagorean identity. So rewrite this as 1 minus cosine squared of x over 2. And that didn't really go anywhere. You might be able to use sine of, in fact, yeah, I believe this is what I did. Right. Yes, this is exactly what I did. So I used, rather than using the Pythagorean identity, I used the half angle identity. So that sine of x over 2 equals plus or minus, this is the identity. Hopefully you can read it. Sometimes the white doesn't render very well. Sine of x over 2 equals plus or minus root 1 minus cosine of x over 2. So this is really nice on the one hand because it's going to rewrite, it's going to change the sine, the half angle, into just an x, which is really promising because cosine is given as just cosine of x. It's not a half angle. Sometimes what is oftentimes the sort of difficult part of using these half angles is the plus or minus bit. But in this situation, we kind of don't need to worry about it because we're going to be looking at sine squared. So if you were to imagine like squaring this whole thing, sine squared, the square just removes the square root and the plus or minus that came from the square root property. The squaring just completely removes that. So it's not ambiguous, it becomes completely well defined. So that's what I'll do. I'll rewrite this right-hand side. We get cosine of x is equal to 2 times sine squared of x over 2. Well, again, the squaring part will just completely get rid of the radical. So this becomes 2 times 1 minus cosine of x over 2. And yeah, this is starting to look pretty solid. So if we multiply through by 2, cosine of x equals 1 minus cosine of x, yeah, this is looking real good. If we add cosine to both sides, then on the left we would have 2 cosine of x equals 1. So we're solving. Where does cosine of x equal 1/2? If you didn't follow that, just like take a second, pause the video, solve this thing for cosine. That's all. Cosine of x equals 1/2. Ah, this one's nice and easy to solve. We don't even need to do the business of, oh, rewrite it as theta and then rewrite it in terms of x. No, it's just saying, let's see, and I should have given an interval. This is specifically, we want to find the solutions over 0 to 2 pi. So yeah, where does cosine of x equal 1/2 on 0 to 2 pi? Well, cosine of x equals 1/2 at x, x equals pi over 3, and negative pi over 3, but we want our solutions between 0 and 2 pi, so 2 pi minus pi over 3, which is 5 pi over 3. So, yep, that's it. And again, if you want to check your solutions, just start with the original equation for sure. Graph these things out, and you can do the exact same thing as like choose your option. You can either graph both of these and see where they intersect, or you can subtract 2 secant x over, which that's what I would do, and then graph cosecant squared of x over 2 minus 2 secant x and see, again, over the domain of 0 to 2 pi, see where those things cross the x-axis. All right, let me get a new page, and I have just a couple more examples to look at. How many more? 3 more examples. Yeah, it's already getting to be kind of a long video, but that's okay. I just want to give a lot of examples. So the next one we'll solve, real similar to the first one that we solved. Sine of 3x equals 0. So, and this would be a good place, if you're still watching this video, this is a real good place to stop the video, try to solve this on your own. Or if you need to kind of go back to when we solved, where is sine of 3x equal to -1? I guess I just showed the solutions, right? This is my solutions page, but still, you saw sine of 3x equals -1, and follow along with that that procedure to see if you can solve this. Where does sine of 3x equals 0? All right. So how would I solve this? Well, again, I'm going to think about where does sine of theta equal 0? There are 2 places. It's when theta equals 0 and when theta equals pi. So we're solving where does 3x equal 0 or pi. That's when x equals 0 or pi over 3. So we've got 2 solutions so far. Is that all of the solutions? No, it's not. What's the period of sine of 3x? We already saw this. We answered this earlier. The period of sine of 3x is 2 pi over 3. So to each of these values, 0 and 2 pi over 3, I'm just going to continuously add 2 pi over 3. And again, I didn't add in my interval. Just assume it's the standard interval from 0 to 2 pi. So we're just going to add 2 pi over 3 onto each of these until we push ourselves out of this interval from 0 to 2 pi. So 0 plus 2 pi over 3 is 2 pi over 3. Pi over 3 plus 2 pi over 3 is pi. 2 pi over 3 plus 2 pi over 3, 4 pi over 3. 2 pi over 3 plus pi is 5 pi over 3. And if I add 2 pi over 3 onto either of these, I push myself out of this interval. Be really careful, because if I add 4 pi over 3, 2 pi over 3 plus 4 pi over 3 is what? It's 6 pi over 3, which is 2 pi. So you might think, what, shouldn't we add that in? No. 2 pi is not included in this interval. So kind of a little trap set for you there. Yeah, 2 pi technically would be a solution, but 2 pi is not included in this interval. So those are the 6 solutions. Suppose that this was like a part A and a part B question, where part A says, what are the solutions over 0 to 2 pi, and part B says, what are all of the solutions everywhere? It still just comes from this. It's this exact same thing. So the solutions everywhere are x equals, let's see, I guess it would just be 2 pi over 3k, and x equals pi over 3 plus 2 pi over 3. Okay, so this first one is technically 0. 0 plus 2 pi over 3k, but 0 plus 2 pi over 3k is just 2 pi over 3. So where k is an integer. So those are all of the solutions. All right, let's do 2 more. See if we can keep this video under 30 minutes. Does anybody even watch these for 30 minutes? I kind of don't think so. I looked at some of like the stats the other day. Looked like the average viewing time was about 4 minutes. I don't know. Is anybody even getting the answers from these videos in 4 minutes? I don't know. Maybe. I need to figure out how to answer these questions in 4 minutes or less. Thanks, TikTok. Right. So here's the next one. Let's try to solve sine of 2x equals 2 cosine squared of x on the interval from 0 to 2 pi. Let's see. And again, take a second, pause the video, play with this on your own. And I'll say too, before I start solving this, I'm sure that there's more than one way to solve these questions. So the way that if you find a way to solve this thing that is different from me, it doesn't mean that you did it wrong. It's all about the solutions. If you're able to get to the solutions, then that's really all that matters. All right, so how did I do this? Well, I first looked at this and I said, yeah, okay, well, I have my choices of identities. I could try rewriting cosine squared. I could try rewriting sine of 2x. The reason my choice was to rewrite sine of 2x because there's only one option. Cosine squared, there's actually quite a few options of how to rewrite cosine squared. So I'm just going to choose sine of 2x because that only has one identity. Sine of 2x is equal to 2 sine of x times cosine of x equals 2 cosine squared of x. Divide through by 2 to make this a little bit simpler. Sine of x times cosine of x equals cosine squared of x. And from this step, I can see quite a number of people making a very, very grave mistake. What is that mistake? They might say, look, both sides have this factor of cosine, which is a great observation, and we are going to use that. At least in my solution, I'm going to use that. But the big mistake that somebody might make is thinking, well, I'm just going to divide that cosine out. And then this reduces just to sine of x equals cosine of x. They solve that. What happens if you do that? You're eliminating a couple of the solutions. Let me show you. So instead of dividing through by cosine, I'm going to solve this thing for 0. Personally, I always prefer to keep my highest degree positive. So I'm essentially just going to subtract sine x cosine x over, but I'm going to rewrite it this way. So it's going to become cosine squared of x minus sine of x cosine of x equals 0. And now I can start thinking about factoring, not dividing out, but factoring out the cosine. So if I factor out cosine from this, then I get cosine of x times cosine of x minus sine of x equals 0, right? So if I plug this cosine back in, there's cosine squared, there's my negative sine x cosine x. So from here, remember back to college algebra, you might not remember this. There's this handy little property of the real numbers, which is that we call it the zero product property. When you have a product of two numbers, and these are, well, yeah, they are functions. You can think of them as sort of behaving like numbers do, because once you plug in some x, they become numbers. If you have a product of two numbers that's equal to 0, then you can solve that because that implies that one or both of those products are 0. So the solutions, in other words, the solutions to this this factored form is when cosine of x equals 0 or when cosine x minus sine x equals 0. So we'll solve those. Where is cosine of x equal to 0? Well, that's when x is pi over 2, 3 pi over 2, at least on one trip around the sun. The other equation is, where does cosine of x minus sine of x equal 0, which is equivalent to saying, where does cosine of x equal sine of x? Yeah. Take a second, if it's not obvious to you, and try to figure that out. Where does cosine of x equal sine of x? Well, the only times that they equal each other are at certain multiples of pi over 4. And in particular, in those multiples of pi over 4 that land in quadrants 1 and 3, where x and y share the same sign, positive or negative. So cosine of x equals sine of x at x equals pi over 4, which is in quadrant 1, or 5 pi over 4, which is in quadrant 3. So those are the 4 solutions. X equals pi over 2, 3 pi over 2, x equals pi over 4, and 5 pi over 4. Those are the 4 solutions to that problem. All right, one more. I've got 4 minutes to do this in under 30 minutes. All right, let's solve. Where does cosine of x equal sine squared of x over 2? Again, take half a second, pause the video, see if you can solve this. Surely there are multiple ways to solve it. The first thing that we're going to need to do is use some kind of identity. And again, we've already seen this trick previously, but I think that the way I would solve this thing out is I'd rewrite sine squared. Yeah, because sine of x over 2 is equal to plus or minus root 1 minus cosine of x. So when we square this, it just becomes sine squared of x over 2 equals 1 minus cosine of x over 2. So I'll do that. Cosine of x equals 1 minus cosine of x over 2. Multiply through by 2. So 2 cosine of x equals 1 minus cosine of x. Add cosine of x to either side. We get 3 cosine of x equals 1. So divide through by 3. Cosine of x is 1/3. That's not a standard output. So this is not something that we can just solve off the top of our head. With the unit circle, you'll have to use a calculator. So x is equal to cosine inverse of 1/3. But remember, cosine inverse only outputs its range is from 0 to pi. So it won't catch the equivalent or the other solution that is occurring from pi to 2 pi. And that solution would be 2 pi minus cosine inverse of 1/3. So just a really quick kind of like justification of what I'm saying. So we're solving, where does cosine of x equal 1/3, which would probably be, let's see, cosine of x equals 1/2 at pi over 3. So it's like a little steeper than that. So like right here. That's one of the, geez, I can't draw a straight line. What is going on? What is going on? Why can't I draw that line? So here's one solution to cosine of x equals 1/3, but then the other solution is this same thing reflected over the x-axis down here. So these both have the same solution right there. This is the x that leads to cosine of x equals 1/3. And the inverse function is giving this top one. It's going to give us this top one. We have to deduce the bottom one here. So these are the two solutions. And let's see, just for a decimal approximation, what are these? It's x is approximately 1.23096 and 5.05223. Those are the solutions. And I've got exactly 50 seconds to go until this is at 30 minutes. I did it, everybody. It's not TikTok length, but maybe it's YouTube length. I don't know. If you watched all the way to this, would you like comment and let me know? That would be incredible. The other thing that you can comment and let me know is if you have any questions at all. I'll be happy to answer them.